On the 1st of May, 1960, a Lockheed U-2 piloted by Francis Gary Powers was brought down near Sverdlovsk by a salvo of 14 S-75 surface-to-air missiles. The Joint Intelligence Committee briefing that landed on the desk of the Chief of the Air Staff, Sir Thomas Pike, 3 days later ran to 11 pages and contained a single underlined sentence in its conclusion. The operational ceiling of 70,000 feet, long regarded by the Royal Air Force as a sanctuary, no longer existed. The Soviet missile, designated SA-2 Guideline by the Western Alliance, had reached an aircraft cruising at roughly that height. Whitehall absorbed the implications slowly. Bomber Command's V-Force, the Vulcans and Victors and Valiants stationed at Scampton and Wittering and Marham had been built around the doctrine of high-altitude penetration. That doctrine was now, in the words of Air Vice Marshal Kenneth Cross, written in a memorandum dated the 17th of May, demonstrably obsolete. The Cabinet Office Defence Committee met on the 23rd of May in the wood-panelled room at Storey's Gate. The minutes, declassified in 2004 and held at the National Archives under reference C.A.B. 131/23, record Harold Macmillan asking a question that would dominate British air policy for the next decade. He wanted to know whether any aircraft in the Royal Air Force inventory could survive over Soviet territory. The Secretary of State for Air, George Ward, answered that the Canberra could not, the Hunter could not, and the V-bombers, on present assumptions, would suffer attrition rates that no Treasury submission could support. There was, however, one airframe entering squadron service that operated on entirely different principles. Ward referred to it by its English electric project number P-1-B, though by then the press and the pilots already called it the Lightning. What made the Lightning relevant to that conversation was not its armament, which was modest, nor its range, which was poor by any reasonable measure, but the manner in which it gained altitude. Where the V-bombers laboured to reach their cruise height over a span of 20 minutes or more, the Lightning could be at 50,000 feet within 3 minutes of brake release. The implication, slowly grasped by the planners at the Air Ministry on King Charles Street, was that an aircraft which arrived at altitude that quickly and which could maintain supersonic speeds in a steep climb presented the SA-2 with a target geometry the missile had not been engineered to engage. The Guideline's command guidance system required the radar operators at Soviet sites to track and predict an aircraft's flight path. A Lightning climbing vertically at Mach 1.3 changed that path faster than the missile solution could update. This was not theory. By the autumn of 1960, Air Fighting Development Squadron at Coltishall had run a series of intercept exercises against simulated SA-2 engagement parameters supplied by the Royal Aircraft Establishment at Farnborough. The results, circulated under cover note RAETM Aero 947, showed that a Lightning Mark I pulling 4G in a climbing turn at 40,000 feet could, under specific conditions, generate a missile miss distance exceeding 1,500 feet. That was sufficient to defeat the warhead's lethal radius. The aircraft had, almost by accident, become the only British platform with a credible answer to the Sverdlovsk problem. The Air Council took note. The orders for further marks of the Lightning, which the Treasury had been resisting on grounds of unit cost, were quietly accelerated. The drawing office at Warton Aerodrome on the Lancashire coast a few miles east of Blackpool occupied a long, single-storey building that had been thrown up in the war years and never replaced. It was here, between 1948 and 1954, that William Edward Willoughby Petter and his successor Frederick Page produced the design that would become the Lightning. Petter himself was a difficult man, by all accounts, and he had left English Electric for Folland by the time the prototype P1 flew in August 1954. But the configuration he sketched on a single sheet of cartridge paper in the spring of 1949 remained the foundation of the aircraft, and it was a configuration unlike anything else then under development in the Western world. The peculiarity lay in the engines. Petter had concluded that to achieve the performance the specification F-23/49 demanded, supersonic flight in level cruise and a climb rate that would place the aircraft at operational altitude before any conceivable interceptor could respond, he required 2 Rolls-Royce Avon turbojets of the largest available thrust. The aerodynamic problem was where to put them. A side-by-side arrangement, as used in the contemporary Gloucester Javelin, produced excessive frontal area and consequent drag. A wing root installation, as on the de Havilland Comet, was structurally unsuitable for an aircraft expected to pull 7G in combat. Petter's solution was to stack the engines vertically within the fuselage, one above the other, with the upper unit offset slightly to allow the intake ducting from the single nose intake to feed both. The arrangement was structurally efficient and aerodynamically clean. It was also, as the costing department at Warton noted in a memorandum dated the 11th of November 1953, a maintenance nightmare. Removing the lower Avon required the upper Avon to come out first, or at minimum to be partially withdrawn. A complete engine change that took 4 hours on a Hunter could occupy a Lightning ground crew for the better part of 2 working days. The Air Ministry's Director of Operational Requirements, Air Commodore Geoffrey Tuttle, raised this objection in writing on the 2nd of February 1954. The reply from English Electric, signed by Page, conceded the point, but argued that the performance gains justified the penalty. Tuttle marked the file and moved on. He had little choice. No other British manufacturer was offering anything remotely comparable, and the Air Staff specification F-155, then being drafted, would shortly demand even more of the airframe. The intake itself was a further complication. The original P1 had used a simple circular nose intake, but supersonic flight required some form of compression management, and the production Lightning incorporated a fixed conical center body that housed first the AI-23 airpass radar and later the AI-23B variant. The cone was a compromise. It worked adequately at speeds up to about Mach 1.7 and degraded thereafter, which placed an upper limit on the aircraft's dash speed that no amount of additional thrust could overcome. The Treasury's chief scientific advisor, Sir Solly Zuckerman, in a paper circulated to the Defence Research Policy Committee in March 1957, calculated the unit cost of a single Lightning Mark I at approximately £370,000 sterling against a Hunter Mark VI at roughly 110,000. The figure horrified the accountants at Great George Street. Duncan Sandys, then Minister of Defence, attempted to cancel the programme outright in his 1957 White Paper. He failed narrowly, and the Lightning survived to enter squadron service with 74 Squadron at Coltishall in June 1960. Roland Beaumont, the chief test pilot at English Electric, had flown the prototype P1 on its maiden flight from Boscombe Down on the 4th of August 1954. He was 44 years old, a former Hawker Tempest pilot who had commanded a Tempest wing over Holland in the closing months of the European War. And he kept a meticulous logbook in green ink. The entry for the 11th of January 1957, when he first took the second prototype P1A to its design ceiling, occupied half a page. The aircraft, lifting off the runway at Warton with both Avons in full reheat, had reached 40,000 feet in 2 minutes and 40 seconds. Beaumont's penciled marginal note, preserved in the company archive at the British Aerospace Heritage Centre, read simply, "Performance exceeds specification by margin, requiring re-examination of all previous estimates." The re-examination occupied the Royal Aircraft Establishment for the next 18 months. The flight test reports, designated A and A-E-E Boscombe Down, Series 91, 14 through 91, 23, established a series of performance figures that no contemporary aircraft in NATO service could match. Time to 50,000 feet from brake release, 2 minutes and 58 seconds, with the aircraft passing through Mach 1 at approximately 15,000 feet during the climb. Time to the service ceiling of 60,000 feet, under 4 minutes. Sustained turn rate at 36,000 feet at Mach 0.9, 9.2 degrees per second, which exceeded the figure for the contemporary North American F-100 Super Sabre by roughly 2 degrees, and was comparable to the Lockheed F-104 Starfighter then entering Luftwaffe service. The Lightning could also accelerate from level cruise at Mach 0.9 to Mach 1.6 in under 50 seconds at 36,000 feet, a figure the test pilots at Boscombe Down initially refused to believe and required 3 separate flights to confirm. What these numbers meant in tactical terms was not immediately obvious to the planners at the Air Ministry. The aircraft had been specified as a bomber destroyer, optimized for the high-altitude intercept of Soviet Tupolev Tu-16 Badger and Myasishchov M4 Bison aircraft approaching the British Isles. The performance margins Beaumont had demonstrated suggested a quite different role. A Lightning scrambled from cockpit alert could be at the altitude of an incoming Soviet bomber and crucially in a position to engage it, in less time than the bomber required to traverse the warning radar coverage of the chain-home extra-low system. More than that, the climb performance opened a tactical possibility that the original specification had not contemplated. An aircraft that could reach 50,000 feet in under 3 minutes could also, theoretically, evade a missile launched against it from below. The implications of this were first explored systematically by squadron leader Jimmy Dell, who had taken over from Beaumont as chief test pilot in 1963. Dell flew a series of trials in the autumn of that year against simulated SA-2 engagement geometries, using the radar tracking facilities at Aberporth on the Cardigan coast. His report, submitted to the Operational Requirements Branch on the 14th of December 1963 under file reference AVRO/OR 397, established that a Lightning conducting a maximum rate climbing turn at the moment of missile launch could generate flight path changes that exceeded the SA-2's command guidance update rate. The aircraft had become, in effect, a missile-evading platform. The doctrine that grew from this finding would shape Lightning operations for the next 25 years. The procedure that emerged from Dell's Aberporth trials was codified in Air Publication 10119, the Lightning Mark III Pilot's Notes, in a section titled simply Evasive Action Against Surface-to-Air Guided Weapons. The document, issued in revised form in March 1965 and held in the Royal Air Force Museum archive at Hendon, ran to 4 pages. Its instructions were precise to the point of being clinical. They assumed a pilot at medium altitude, between 30 and 40,000 feet, who had received either a visual sighting of a missile launch plume or a warning from his AI-23 radar warning receiver. The latter operating in the S-band frequency range between 2.7 and 3.1 GHz, which corresponded to the fan-song acquisition radar that guided the SA-2. The first action, on detection, was to roll the aircraft inverted. This was not a maneuver most pilots had previously contemplated as a defensive technique, but it served two purposes. It placed the canopy in the line of sight of the missile, allowing the pilot to maintain visual contact with the threat, and it positioned the aircraft for the second and decisive action, which was a 4G pull through the vertical with both Avons in full reheat. The reheat selection was critical. The Lightning's twin, Avon, 210 engines produced approximately 14,000 pounds of thrust each in dry power and approximately 16,300 pounds with reheat engaged. The thrust-to-weight ratio of a Lightning Mark III with half fuel and a pair of Firestreak missiles approached unity, which meant the aircraft could sustain a vertical climb without losing speed. No other operational fighter in NATO service in 1965 could do this. The pull-through was to be initiated when the missile had closed to within approximately 6,000 yards, judged either visually by the size of the missile's exhaust flame or by the radar warning indicator's signal strength. The 4G load factor was specified because it represented the maximum sustainable maneuver at altitude without bleeding excessive speed, and because the airframe stress at higher loadings produced fatigue concerns that the design office at Warton had not fully resolved on the early marks. The pilot held the 4G pull until the aircraft was passing through the vertical, at which point the SA-2, which could pull approximately 7G, but could not adjust its command guidance solution at the rate the Lightning was changing its flight path, would either pass behind the aircraft or lose lock entirely. The procedure assumed, correctly in most engagement geometries, that the missile's proximity fuse would not detect the aircraft at the missed distance achieved. The training for this maneuver was conducted at the Lightning Operational Conversion Unit at Coltishall, later moved to Coningsby, under the supervision of instructors who had themselves practiced the procedure on simulated profiles flown against radar-controlled tracking targets at the West Froy Range in Wigtownshire. Pilots were required to demonstrate the evasion sequence on 3 separate sorties before they were declared combat ready. The minimum reaction time, from missile launch detection to the initiation of the inverted pull, was specified as 3 seconds. Anything longer was considered to compromise the geometry of the escape. Squadron leader Mike Hobson, who flew Lightnings with 56 Squadron at Wattisham between 1966 and 1969, recalled in an oral history recorded by the Imperial War Museum in 1998 that the procedure was practiced in his squadron at least once a fortnight. The pilots called it, with the dry humour characteristic of the period, the bunt and burn. It was the only answer the Royal Air Force possessed to the SA-2 threat, and it worked. Royal Air Force Binbrook stood on the Lincolnshire Wolds, 370 feet above sea level, on a chalk ridge that ran roughly northeast from Market Rasen. The station had been built in 1940 as a bomber airfield and had housed Avro Lancasters of 460 Squadron Royal Australian Air Force during the war. By the autumn of 1962, it was home to 56 Squadron and 64 Squadron, both flying the Lightning Mark II, and to a pair of corrugated iron sheds at the southern end of the main runway that the official station diary referred to as the Quick Reaction Alert Facility. The sheds were unheated, lit by single bare bulbs, and contained 2 Lightnings on 5-minute readiness around the clock. The pilots, in full pressure suits, sat in adjacent rooms watching the telephone. The Cuban Missile Crisis began, for the Royal Air Force, on the evening of the 22nd of October 1962, when Fighter Command moved to Alert State 3 at 2200 hours Greenwich Mean Time following the broadcast of President Kennedy's address from the White House. The signal traffic from Headquarters Fighter Command at Bentley Priory, transmitted on the secure landline network to all sector operations centres, instructed quick reaction alert facilities to reduce their readiness state from 15 minutes to 5. At Binbrook, at Wattisham in Suffolk, at Leuchars in Fife, and at Leconfield in the East Riding, pilots were summoned from their married quarters or from the officers' mess and walked across Dark and Pan to the alert sheds. They remained there, in rotating shifts of 4 hours, for the next 6 days. The procedure for a scramble was straightforward in description and ferociously demanding in execution. A telephone, painted red, sat on a small table inside each shed. When it rang, the pilot lifted the receiver and listened. The voice from the Sector Operations Centre at RAF Neatishead, or in the case of Leuchars from RAF Buchan in Aberdeenshire, would announce a target bearing, range, and altitude, and would conclude with the word scramble. The pilot replaced the receiver, walked the 11 paces to his aircraft, climbed the ladder, strapped in with the assistance of a crew chief, and started the lower Avon. The upper engine could be brought online during taxi. From the moment the telephone rang to the moment the Lightning lifted from the runway, the standing requirement was 4 minutes. The squadron records at Binbrook for October 1962 show that the average achieved time was 3 minutes and 12 seconds. What the pilots were scrambling against during the Cuban week was rarely, if ever, a Soviet aircraft. The Tu-95 Bear flights that probed the United Kingdom air defence region from the north routinely declined to enter the period of heightened alert. The targets, when they materialized, were generally civilian airliners that had drifted from their assigned tracks, or NATO aircraft whose identification friend or foe transponders had failed. But the procedure remained the same, and the aircraft launched with live Firestreak missiles on the wing pylons. Wing Commander Dennis Caldwell, who commanded 64 Squadron at Binbrook through the crisis, wrote in his diary on the 28th of October, the day Khrushchev announced the withdrawal of the missiles from Cuba, a single line: "No scrambles since the 24th, but the men have not slept properly in a week." The quick reaction alert system, established in its essential form during those days, would continue largely unchanged until the Lightning's withdrawal from frontline service in 1988. The Tupolev Tu-Ninety-Five Bear, designated Bear D in its maritime reconnaissance variant, was a 4-engine turboprop aircraft of considerable size, approximately 162 feet in length, with contra-rotating propellers driven by Kuznetsov NK-12 engines that produced a distinctive acoustic signature detectable on the SOSUS hydrophone arrays in the Greenland-Iceland-United Kingdom gap long before the aircraft entered British radar coverage. From 1963 onwards, flights of 2 or 3 Bears, operating from bases at Olenia on the Kola Peninsula and later from Saki in the Crimea, conducted regular probing missions down the Norwegian coast, around the North Cape, and into the airspace approaches to Scotland and the Faroes Iceland Gap. The Royal Air Force tracked these flights through the radar stations at Saxe-Voord on Unesty in the Shetlands, at Buchan, and at Bulmer on the Northumberland coast. The intercept procedure was practiced, refined, and eventually became routine. A bear detected at extreme range by the Type 85 radar at Saxe-Voord, operating on a frequency of approximately 2,900 MHz, would be reported to the Sector Operations Centre at Buchan, which would alert the Quick Reaction Alert flight at Leuchars. A pair of Lightnings, typically from 11 Squadron or 23 Squadron, would be scrambled to intercept the Soviet aircraft at a position calculated to place the British fighters astride the Bear's projected track at the earliest possible moment. The intercept geometry was important. The Lightning's poor endurance, even with the ventral fuel tank fitted to the Mark III and later Marks, meant that the aircraft could not loiter at altitude for extended periods. A typical intercept sortie from Leuchars to a position 300 miles north of the Shetlands and back to base consumed approximately 55 minutes of airborne time, of which perhaps 12 minutes could be spent in the company of the Soviet aircraft. Once visual contact was established, the Lightning pilot would close to a position abreast of the Bear's port wingtip, typically at a distance of approximately 40 feet, and there he would remain. The gun cameras of the Lightning, mounted in the upper fuselage forward of the cockpit, recorded the encounter in color film. The Bear's crew, visible through the heavily framed cockpit glazing, would generally wave. Photographs would be exchanged. The Soviet rear gunner, manning the twin 23mm cannon in the tail position, would on occasion display reading material, sometimes including, according to debriefing reports filed at Leuchars in the late 1960s, copies of Pravda, or, more memorably, photographs of his family. Wing Commander Mike Stretton, who commanded 11th Squadron at Leuchars between 1972 and 1974, recalled in correspondence held at the Royal Air Force Museum that the encounters were almost invariably professional, and that on more than one occasion Soviet airmen had held up handwritten signs in English bearing greetings, or, on the festive occasion of Christmas, simple seasonal messages. The gun camera footage from these intercepts was processed at the Joint Air Reconnaissance Intelligence Centre at Brampton in Huntingdonshire. The film was analysed for any modifications to the Soviet aircraft, for new aerial arrays that might indicate signals intelligence equipment, and for any indications of armament changes. The intelligence value was substantial. A Bear photographed in 1968 by a Lightning of 23 Squadron carried a previously unknown wingtip pod that, on examination at Brampton, proved to be associated with the big bulge surface search radar then being introduced to Soviet maritime aviation. The footage from these encounters, much of it still classified at the time of writing, formed one of the most consistent intelligence streams the Royal Air Force generated throughout the Cold War. The Lightning, Mark VI, entered squadron service with 5 Squadron at Binbrook in December 1965. It represented the final development of the airframe and incorporated changes that the operational squadrons had been requesting since the Mark I had first flown. The most visible alteration was a substantially enlarged ventral fuel tank, increasing internal fuel capacity from the original 716 gallons to approximately 1,024 gallons, and the provision for 2 overwing ferry tanks of 260 gallons each, mounted on pylons above the wing rather than below. The overwing arrangement was unusual and reflected a specific aerodynamic constraint. The Lightning's wing, swept at 60 degrees on the leading edge, carried no underwing hardpoints in its original configuration because the ground clearance with the undercarriage extended would not accommodate them without lengthening the gear legs, a modification the design office at Warton had judged structurally unjustifiable. The air staff requirement for the Mark VI had been issued in 1962 as Operational Requirement 339, which specified an aircraft capable of an unrefueled combat radius of approximately 400 nautical miles, a figure the earlier Marks could not approach. The Mark I, in operational configuration with 2 Firestreak missiles and full ammunition for its 2 30mm Arden cannon, had a combat radius of approximately 150 nautical miles, which constrained its utility to the immediate air defence of the British Isles and made deployment to overseas theatres operationally awkward. The Mark VI achieved approximately 340 nautical miles, which represented a substantial improvement but still fell short of the requirement. The discrepancy was the subject of considerable correspondence between the Air Ministry and English Electric, much of it preserved in the files of the Operational Requirements Branch at the National Archives under reference AIR 20/112. The armament of the Mark VI reflected a separate technical evolution. The Firestreak infrared missile, which had armed the earlier Marks, had been developed by de Havilland Propellers at Hatfield in the 1950s and entered service in 1958. It was a tail chase weapon, requiring the launching aircraft to maneuver into the rear quarter of its target, and its seeker, cooled by liquid ammonia, was sensitive to background thermal clutter. Its successor, the Red Top, also a de Havilland product, entered service in 1964 and addressed several of the Firestreak's limitations. The Red Top's seeker, cooled to a lower temperature and operating in a shorter infrared waveband, could engage targets from forward hemisphere aspects under favorable conditions, and its larger warhead of approximately 31 pounds of high explosive substantially increased lethality. The Lightning Mark VI carried two red tops on the forward fuselage pylons, with provision retained for the older Firestreak when stocks of the newer weapon were limited. The engineering arguments that surrounded the Mark VI development were not confined to range and armament. The Treasury, in correspondence dated the 8th of March 1963 between Sir Richard Way at the Ministry of Aviation and the Permanent Secretary at Great George Street, raised the possibility of cancelling further Lightning production in favour of an accelerated procurement of the McDonnell F-4 Phantom II from the United States. The Phantom offered superior range, a more capable radar, and a heavier weapons load at a unit cost that the Treasury believed would prove competitive once development costs were amortized. The Air Staff resisted, arguing that the Lightning's performance characteristics, particularly its climb rate and high-altitude maneuverability, remained unmatched. The argument was settled by compromise. Lightning production continued, but at reduced numbers, and the Phantom was procured in parallel. Royal Air Force Akrotiri occupied a peninsula on the southern coast of Cyprus, approximately 5 miles southwest of Limassol. The station had been established in 1955, and from 1967 onwards housed the Near East Air Force Strike Wing, which from January 1967 included 56 Squadron operating Lightning, Mark IIIs, and later Mark VIs. The squadron's role was the air defence of the sovereign base areas, the protection of the Cyprus airspace under the terms of the 1960 Treaty of Establishment, and the deterrence of Soviet maritime aviation operating from bases in the Crimea and from the Soviet naval squadron based at Latakia in Syria. The Lightning's deployment to Akrotiri presented operational difficulties that the airframe had not been designed to accommodate. Ambient temperatures on the dispersal pans regularly exceeded 35 degrees Celsius in summer, which degraded the Avon engine's thrust and substantially reduced the aircraft's already marginal range. Pilots flying from Akrotiri kept their sortie planning to short radius intercepts and accepted that any deeper penetration of the eastern Mediterranean would require tanker support from the Victor K Mark II aircraft of 55 Squadron based at Marham. Royal Air Force Gütersloh in Westphalia presented a quite different operational environment. The station, the easternmost Royal Air Force base in West Germany, lay approximately 70 miles from the inner German border. 19 Squadron and 92 Squadron, both flying Lightning Mark IIs and later Mark II-As, were based there from 1965 onwards. The Quick Reaction Alert mission at Gütersloh was conducted under different rules of engagement from those applied in the United Kingdom. The reaction time was shorter, the airspace congested, and the proximity of Warsaw Pact forces meant that a scrambled Lightning could be in contact with hostile aircraft within minutes of brake release. The squadrons at Gütersloh practiced low-level intercept profiles that the home-based units rarely flew, operating beneath the radar coverage of East German and Soviet ground stations and engaging targets at altitudes below 500 feet. The aircraft's performance at low level, while inferior to its high-altitude figures, remained competitive against the contemporary Soviet Mikoyan Gurevich MiG-21, then in widespread service with Warsaw Pact air forces. The retirement of the Lightning began, in formal terms, with the disbandment of 19 Squadron and 92 Squadron at Gütersloh in 1976 and 1977 respectively, both squadrons re-equipping with the Phantom F-G Mark I. The Cyprus-based 56th Squadron returned to the United Kingdom in January 1975 and likewise converted to the Phantom. By 1980, only the two Binbrook squadrons, 5 Squadron and 11 Squadron, retained the aircraft in frontline service. They flew Lightning Mark 6s, supplemented by a small number of Mark 3s retained for training purposes. The Binbrook Lightnings continued to perform the Northern Quick Reaction Alert mission, sharing the task with Phantom-equipped squadrons at Leuchars and Wattisham until the final disbandment of 11 Squadron on the 30th of April 1988. What the Lightning's withdrawal represented, in strategic terms, was the end of a particular British answer to a particular Soviet threat. The aircraft had been designed in the late 1940s to a specification that anticipated high-altitude bomber penetration of British airspace. By the time it left service, that threat had been replaced by long-range cruise missiles, low-level penetration tactics, and the emergence of Soviet fighters whose performance approached or exceeded the Lightning's own. The escape profile against the SA-2, which had once represented the Royal Air Force's only credible answer to the surface-to-air threat, had become a procedure of historical interest rather than operational necessity. The aircraft that flew its last sortie from Binbrook had been, for nearly 30 years, the fastest climbing fighter in any Western Air Force. It would not be surpassed in that single metric until the introduction of the Eurofighter Typhoon 2 decades later.